Given g of s equals 2s plus 1 over s squared and an input signal as an impulse, find the system response. Now this is kind of similar to the previous video that I had regarding finding total response, but in this case we are given a open loop transfer function, so we have to find the closed loop transfer function first before we find the system response. So let's call our closed loop transfer function c of s over our input. So this is our closed loop transfer function. It is going to be g of s. Now g of s is of course the open loop transfer function over 1 plus g of s. So we have to work this out. So we have 2s plus 1 over s squared, 1 plus 2s plus 1 over s squared. Now eventually your s squared would cancel out and you have 2s plus 1 over s squared plus 2s plus 1. Now if you factor this out, it will be 2s plus 1 over s plus 1 squared. So now this is our c of s over r of s. R of s is the input signal. Now we are told that the input signal is an impulse function, meaning that r of s is equal to 1. In the previous video it was a unit step, that's why it was 1 over s. Here is impulse, so that's equal to 1. So we have our closed loop transfer function. Now the system response, because we have to find the Laplace transform afterwards. So the c of s is equal to, since r of s is equal to 1, is only, now what's left is just s plus 1 squared. Now we have to go to t domain, the time domain. That's the system response. And so in order to do that, we have to use partial fraction to kind of separate this in order to find the system, in order to find the Laplace transform of this, because you can't just find it like that. You have to transform it. So this is a for partial fraction. I have to separate. Now when you have a squared, the first one will be just that, and then the second one will be the squared. That's how you do the partial fraction when you're dealing with squared. So the first one will be just that, and then you square it afterwards. If you had a cubed here, you will have s plus 1, and then the second one will be s plus 1 squared, and then you will have c s plus 1 cubed. Okay, so now we have to find a plus b. Now it can be whatever number we find. If it's negative, then it will be minus here. So the plus doesn't mean that both numbers will be positive. It doesn't mean really nothing. So okay, so now partial fraction. Okay, so now we can just I'll do it here. Typically when you're dealing with square, you have to kind of assume that s is some number. Let me put that here. Let's see, so you have a s plus 1 squared plus b s plus 1 is equal to your numerator here, 2s 8 plus 1. So we just have to find some some random numbers, plug in random numbers for s and plug it in to find a and b. So let's assume that s equal to 0. So we have a, if s equal to 0, we have a plus b is equal to 1. Now there's another method, I just can't remember it right now, that's a lot easier to find partial fraction, but that's when you're not dealing with squared, but I can't remember right now. I'll probably search for an example where we don't have a square here. Okay, now let's assume for another s, if s is equal to, you can't put minus 1 though, because then the whole thing would be 0 and you don't want that. So if you have s plus 1 here, minus 1 will make it 0, so you can't choose minus 1, you have to choose another number. So let's pick 1. If s equal to 1, you have 1 plus 1 is 2, 2 squared is 4, so we have 4a plus, if s is 1, so you have 2b. If s is 1, you have plus 3. Okay, so at this point we just need you know, this is just simple math, and I could see that a is equal to 2 and b is equal to minus 1. Okay, and you can double check with me, pure check on that if it's not true, but I feel like it is. A plus 1, yeah. Let's see. 2 the first one is out. Yeah, okay. Alright, so now we have C of S. Going back to original stuff, so we have 2 over s plus 1 minus 1 over s plus 1 squared. And now this is practically easy now for finding the Laplace transform for our system response in time domain. Now you can go to your Laplace table, and this is pretty straight. 1 over s plus 1, let me see here, that's e to the power minus 1t. I'm not sure if we have to put a constant or not. Let me see. Okay, and that would be t e minus, so that would be plus t e to the power minus t. Yeah, and that's pretty much it. So this is your system response. That's it. So I have some problems also with root locus and body plot, so I'm going to upload that later on. Thanks. If you have any questions, let me know. All right, thanks.